So, can you send the notes of previous doubt discussion of physics?
Yeah, I will send that also. No, per relative motion will not be part of the MT4 syllabus. It is up to projectile motion only. Okay, so while you are sending me the doubts, I'm going to just put up some standard type of questions which we will discuss. Yes, everything to do with projectile motion swarm is involved, including projectile on inclined plane and all that. Okay, part question 41 and 43 from H.C. Verma. So let's begin the discussion with these two questions. So let's start with question 41. Go through it carefully. Okay, Aryan will discuss that also. So 41, 43 and 45. These are the questions I've received so far. Okay, Akshat, we will discuss the questions from worksheet immediately after this. Okay. So just go through question number 41 from H.C. Verma. I will explain the question to you and discuss the solution. Okay, so question 41 says that boy standing on a long railroad car throws a ball straight upwards. The car is moving with a horizontal acceleration of 1 meter per second square, and projection velocity of the ball is given to you 9.8 meters per second square. How far behind the boy will the ball fall on the car? So this question can be solved by separately understanding the vertical motion of the projectile. In this case, it's a vertical projectile. It's more like a vertical motion, along with the horizontal motion of the railroad car. Suppose something like this is happening. There's an acceleration of 1 meter per second square. And this object is projected vertically from here at a speed of 9.8 meters per second square. So what happens is that the object goes up and comes down. But by the time the object comes down, the car has shifted forward. So if the point of projection on the car was this point P, it has now reached here at time t equal to capital T. So we have to calculate this. So this is the displacement of the railroad car during the time. Okay, so you can see that the time of flight for the vertical projectile is 2u by g. We'll take G as 9.8 here, so 2 seconds. So the horizontal displacement of the railroad car during that time. Okay. So as far as that boy is concerned, the projectile will fall at a point which is 2 meters behind him. So this guy present over here who threw the ball upwards, to him it will now look like the ball has fallen down at a point which is 2 meters behind him. Okay. So Parth, hope this question is clear to you.
Yes, sir. Got it.
Okay, very good. Let's come to question. In between, I received some more questions also, so we'll discuss those. 31, 33 from Akshat. Okay, then we'll come back to 43. So let's come to question 31. Okay, so let's go through question 31. It says an elevator is descending with a uniform acceleration. To measure the acceleration, a person in the elevator drops a coin at the moment the elevator starts. The coin is 6 feet above. Just a minute. Yeah. So the coin is 6 feet above the floor of the elevator at the time it is dropped. The person observes that the coin takes a time of 1 second. Calculate from this data the acceleration of the elevator. So again, here we will do the question just using the normal concept that both the coin and the elevator in 1D motion, and we will separately solve the motion and see the connection between the two. Though this can also be solved by another method called relative motion equations, which we'll be discussing also soon. But here there is no need in this case to apply relative motion. We can also solve it by individually understanding the motion of each of the things. That is the elevator and the coin. But as you need to understand, once you release the coin, it is in free fall. So it will have an acceleration of g. Okay, so the coin is initially at a height above the elevator's floor of 6 feet. So now what happens is the moment you release it, the coin starts going down with an acceleration of g, whereas the elevator is going down with an acceleration of e. Okay. So by the time the coin hits the floor of the elevator itself has also descended. So at some time t, the coin has reached here. So this is the displacement of the coin, and during that time, this is the displacement of the elevator. So you can see that displacement of the coin will be equal to half gt square. Displacement of the elevator is half at square, and the difference of the two is equal to 6 feet. Okay. So now in this g is known, t is known. Okay. A is the unknown quantity which you can solve. You can substitute g in feet per second square. So you will get acceleration in feet per second square, or convert 6 feet to 6 into 3.05 meters. Sorry, 6 divided by 3.05. And g as 9.8 meters per second square. That approach will give you acceleration in meters per second square. Okay, so hope this question is also clear.
Yes, sir.
Okay,
Sir, it's not 33, it's 43.
43. Okay, okay, let's discuss 43. Okay, so 43 is also a question that can be done by relative motion, but here we will solve it by separately solving the motion of the truck and the motion of the ball. So this is now going at a velocity which is given to us as 14.7 meters per second. So acceleration is 0. It's going at uniform velocity. Now a man throws a ball in such a way that it returns to him. Okay, so if it returns to him, that means this is a diagram at t equal to 0. This is how it should look. So the ball that he has thrown should be thrown at some speed like this, so that it goes, and by the time it is 0. So during that time t, the range of the projectile should be equal to the displacement of the truck. So remember, range of the projectile is horizontal component into time, and this is velocity of the truck into time, or u cos theta into 2u sin theta by g. should be equal to, so either we will understand that ux or u cos theta is equal to velocity of the truck, which is 14.7 meters per second. Now this is the motion as observed by a person on the ground. Okay. This is from the ground frame point of view. Now what else is given to you? That the truck has moved 58.8 meters. Okay. And given so 4 seconds. So if time is 4 seconds, now you can also see that so uy will become 9.8 into 4 divided by 2. So the projection velocity as seen from ground frame will be this. And from this you can find u angle of projection. Okay, so hope this first part is clear to both of you, Akshat and
Yes, sir.
Parth, right?
Yes, sir.
Okay. Now we'll discuss about the second part also as seen from, rather this is the second part, speed of and the angle of projection as seen from the road. Okay. Now that is a ground frame observed. Now as far as the person on the truck is concerned or the truck's frame, what do you think the velocity of projection will look like? In the truck's frame, how is the motion of the projectile looking like? It's looking like a vertical motion because it's coming back to the same point. You know? So it will look like a vertical projection with how much velocity? The velocity equal to that uy only. Okay. So as far as the person on the truck is concerned, in his frame, what is happening? The truck's frame, the ball is just going up and coming down. So this projection so 2u by g is equal to t. So u just becomes okay. So we will also see the solution of this type of question later using relative motion concept. But actually, relative motion concept is also an effective way of solving it. But in this type of question, it's not really necessary. We can just solve it like this from the ground frame point of view. Okay, now let's come to 45th. What about question 44? Have you people solved? Question 44, it's quite a tricky question. So Parth, you have solved it and you are sending the answer, or?
Yes, sir, I had solved it.
Okay, very good. Very good. Okay, so since nobody has asked the question, I'm not solving 44 right now. We have a doubt session on, I think Friday or Saturday, one of the days, day after tomorrow, I think Saturday. So in case somebody has not attempted question 44, please try it out, and if you're unable to solve, we'll discuss on that day. Now let's come to question 45. So 45, most likely, what might have happened is the language of the question might not be clear to you. Let me explain. So man is sitting on the shore of a river. He is in line with a 1 meter long boat. So if he's in line, basically what they're trying to say is that, let's say the length of the boat is along this axis. So the man is viewing the boat along that axis. He's on the shore and water like this. Now this length is equal to 1 meter. Okay, this is what the geometry of the question is basically away. Okay. And also given to us that the center of the boat is away from the man by a distance of 5.5 meters. So if we can throw the apple at a speed of 10 meters per second, we have to find the angle of projections range, that is minimum and maximum. So in one case, now you can see one thing interesting over here, that for u equal to 10 meters per second, what is the maximum possible range? It is u squared by g for theta equal to 45 degrees. Let's check out how much that is. So that is 100 by 10 meters. Okay. So this is, you can see that the maximum range is too much. Okay. So it will overshoot the boat. Okay. So that means now if he wants the ball to land at the point A, let's say he projects it at an angle alpha, it will work for alpha, but he can also project it at an angle like this, where theta is 90 minus alpha, and then also it will land like this. So let's find out how much that alpha is. So to land the ball at E, okay. So now this also tells me something, that what happens if alpha is less than 15 degrees? Okay. Then the range will become less than 5.0 meters. And what if alpha is greater than 75 degrees? Then also the range will become less than 5.0 meters. So therefore, for the range to be greater than equal to 5.0 meters, alpha should either be belonging to the interval 0 to 15 degrees. Sorry, should not be 0 to 15. Okay, it should be in the range of 15 degrees to 75 degrees. Alpha should be greater than equal to 15, but less than equal to 75 for this condition. Okay. Now this condition doesn't ensure that we also want that it should not go beyond the point beta. So now next, let's concentrate on the end point B over. Now if he wants to project it such that it reaches the point B, let's say the angle of projection is some beta. So there are two possible solutions for this also now. Like this. So to land at B, the range should be 6 meters. Okay. So U square sine 2 beta divided by G should be equal to 6. Okay. So sine 2 beta will come out to be 0.6. Now this is where I will use a scientific calculator to calculate that 2 beta is either equal to. So if I do sine inverse of 0.6 in a scientific calculator, I'll get only the solution in the first quadrant, okay, which will come out to be about 36.87 degrees. Okay. But I know that it will also work for the complement of that. No? So 180 minus that, so that will be 143. Actually, 0.6 is actually
0.6 will be that 3 by 5. Right?
37, almost 37. Actually, 37 is not exact. It is like 37, 36.9 hota actually. So we take it as 37. Okay, so 140. So beta should be equal to either 18.5 or its complement. So now you see the idea is that if beta is greater than 18.5 degrees, okay, or again let's understand if beta is less than 18.5 degrees, then the range is less than equal to 6 meters. On the other hand, if beta is greater than equal to 71.5 degrees, again the range is less than equal to 6 meters, which also means that if beta is in between 18.5 and 71.5, then the range becomes greater than 6 meters. So we don't want this. We don't want this. Okay. And similarly, this tells me that if alpha is less than 15 degrees or alpha is greater than 75 degrees, the range becomes less than 5 meters. So this is what we don't want. Okay. So we want the angle of projection such that it satisfies both the condition of alpha and beta. Okay. So theta such that the range is greater than equal to 5, but at the same time less than equal to 6 meters. So for that, theta has to belong to either the interval from 15 degrees to 18.5 degrees, or it has to belong in that interval from 71.5 degrees to 75 degrees. So the maths part is a little bit complicated. Okay, so please understand that here what we want is that this interval should not be in our set, and this interval should not be in our set. So look for any values of theta between 0 and 90 such that it's not less than 15, but it's not greater than 75. And at the same time, it is not between 18.5 and 71.75, 71.5. Okay. So in the entire domain from 0 to 90 degrees, we don't want this region. 17.5 is 71.5 and 75. So this region should be avoided. Don't want it to be less than 15. This region should also be avoided. We don't want it to be greater than 75. This region should also be avoided. So we are left with what possible values? We are left with this. Okay, so Parth and Parv, hope the question is clear to both of you. Yes, Parv. Oh, rather Aryan. Sorry, the question was asked by Aryan. Okay, very good. Okay, so little bit complicated in that analysis, in the inequality analysis. Okay, otherwise it's quite normal. Okay, now I'm coming to some questions asked from the worksheet, projectile motion worksheet. So I'll just put up the question numbers on the board, then we can start discussing them. So the 2-dimension motion and projectile motion worksheet, which I've sent the second one. Question number 1, 8, 21, and 24. Okay, let's discuss that. Next. So while you are just going through this solution set, maybe try to minimize this a little more. So next up, we will look at questions from the worksheet. One, 8, 21, and 24. Okay. Right, but I'll discuss those. Okay, Aryan, we'll discuss 25 also. Okay, now let's quickly go to question 1 and 8 first. Okay, so question 1, it says that in 30.5 hours, that is 30 hours and 30 minutes, a balloon drifts so many kilometers north, so many kilometers east, and so many kilometers in the upward direction from its release point. Find the magnitude of its average velocity and the angle that the average velocity makes with the horizontal. Okay. So, very good question here. So, this question is really about handling vectors in 3 dimensions. Okay. So, what you have to understand in this question is that north, south, east, west direction lie in a horizontal plane. Just a minute. Okay, Akshat, I'll discuss that also. Now, coming back to this, what you have to understand that north, south, east, west, they are lying in a horizontal plane. So just imagine a horizontal plane like this, whereas vertical is perpendicular to this. Okay, so if this is a horizontal plane, so let's say we orient our x and y axis such that x axis is pointing west east. This is our x axis, and y axis is pointing from south to north. In that case, our z axis will point along the vertical or opposite to gravity. So this is the main thing. So now what is happening, the particular motion that is talked about over here, it is having a certain amount of displacement first along the 21.5 kilometers north, then 2.88 kilometers, sorry, 9.7 east, and then 2.88 upwards. So it's going like this. Okay. Then eastwards, then no, vertically upwards. So let's see. So the net displacement that is happening now, that is this vector. So we can write the net displacement vector as x I cap plus y j cap plus z k cap. We can find the magnitude of that net displacement. So you can find the magnitude of average velocity as magnitude of average of net displacement divided by time. So the first part you can just use this. Okay. Now the second part, you have to find the angle that makes with the horizontal plane. So that means I can see that if you see this angle, this vector is making some angle with the horizontal plane. Let's say that is theta. So easy way to calculate that theta is, let's say the angle it's making with the z axis is gamma. So the angle of the net displacement with respect to the horizontal plane, which is basically my xy plane, suppose that is theta. So you can see that theta will be equal to 90 minus gamma, where gamma is the angle with respect to the z axis. Now if you see, what is s dot k cap? It is mod s into cos gamma. So cos gamma is basically z divided by root of x square plus y square plus z square. So from this we can find out gamma, and then from that we can find out theta. Because theta is 90 minus gamma.
Sir,
Yes.
sir, I tried finding the resultant of x and y, and then I tried to
वो भी
relate
कर
it with.
सकते हो. You can do like that also. You can take like this, that you can consider one vector like this, let's say s prime, and this is the net displacement s. So s prime is the vector sum of, you know, that y and x, and this has got the, so this angle you can also find out like this. So this theta be such that cos theta is like this. Okay. Now s is of course your x I cap plus y j cap plus z k cap, but s prime is x I cap plus y j cap. So you can see cos theta will come out to be x square plus y square divided by root of x square plus y square plus z square into root of x square plus y square. You can do this way also. So this will also give you the same result that this will give.
Okay, sir.
Okay, so let's move on to question number 8 after this now. We'll also do 9 and 14. So 8, this thing that a hose lying on the ground shoots a stream of water upwards at an angle of 40 degrees to the horizontal. Speed of water is 20 and it leaves the hose as it leaves the hose. Okay. So only thing is here you'll have to work out the cos and sine of 40 degrees using a table. It's not one of the standard. So how high up a wall will it strike? The wall being 8 meters away. So just think of a diagram like this where this is the ground level, this is the wall, and from the ground at a distance of 8 meters from the wall, the hose is projecting water at some u at some angle theta. The water continuously gushes out and hits somewhere. So use your standard equation of trajectory. This will be easiest. Take this as x, this is y. So the equation of trajectory calculate like this: y is equal to so we'll work this out and we'll work this out also. So u is given to us as 20 meters per second. So let's see how much this comes. Okay, so first of all, that tan 40, that will also be pretty close to tan 45. Okay. And this one, sin 80, as I said, is pretty close to 1. It is almost 0.98. So since it's 0.98, what I can do is I can take G as 9.8. Yes, sir. In any case, if G is not given as 10, so 10 to take it as 9.8. So this is 40 meters. So this equation is becoming now this point where it hits the wall. At this point, the x coordinate is 8 meters and the y coordinate is h. So this h is what we want to find out. So this lies on the trajectory. So substitute it here. So h should be equal to 0.84 into 8 into 1 minus 8 by 4. So 4/5 of 8 into 0.84. That will be so this is the easiest way of doing the question because we are not involving time, because we are not writing the time-based equations. You have the option of either using equation of trajectory or you could have used these equations that x is u cos theta t, y is equal to u sin theta t plus minus half gt square. But if you use these equations, then you have to find the time it reaches the wall, then substitute that value of time. So unnecessarily you have to find one variable and then eliminate it. Whereas anything that does not involve solving for time, or the question information does not involve any time, you can skip that step by directly using the equation of trajectory. So hope this question is also clear. Now moving on to the ninth one after this. Just go through the ninth question we'll discuss. Okay, so let's come to the discussion of the ninth question. So the only thing is in this, the calculation is a little bit complicated because we'll have to use feet per second square. So let us look at it in detail. So first let's understand the geometry of it. Okay, projection speed is given, angle is given. Also that the ball is hit from a level which is 3 feet above the ground. Okay, whereas the fielder reaches 7 feet above the ground at the wall, and the wall is 386 feet away from the projection point. So let's put all this in a diagram. So again, we will basically use equation of trajectory, but it's about substitution of the values, which is a little bit tricky here. So this is the ground level, and this is where the wall is present. So the batter who hits the ball, he hits the ball from here at a speed of u at an angle theta, where this is 3 feet above the ground. So the ball, as it goes from here, it's somewhere here. Whereas let's say the fielder who has jumped up in the air, his hand has reached a level which is 7 feet above the ground, and given to us that the speed of projection is 132 feet per second. The angle of projection is 26 degrees. And this distance here is 386 feet. And this will take the value of acceleration due to gravity to be 32 feet per second square. So ultimately we have to find what this gap is. Let's say this gap is h. So to find this gap, first of all, we'll have to set our coordinate frame. So we'll understand that this should be our x-axis, and this should be our y-axis. Okay. So therefore, at this point, let's say the coordinates are x1, y1. So x1 will be equal to 386 feet, and y1 will be this distance, which is 4 feet plus h. That is the height by which he misses the ball. Okay. Now let's come to the trajectory. So equation of trajectory. So tan theta is equal to tan 26 degrees. Let's calculate tan 26. So that's about 0.49, or I can even take it as about 0.5. Okay. And R is u square sine 2 theta by g. So that is 132 squared sine 52 degrees divided by 32 in feet. So sine 52 I can take nearly as sine 53. So it will come nearly 0.8. So 0.8 multiplied by 132 squared divided by 32. So this will give me a range of around 435.6. It's an approximate value. Actually, a more accurate value using sine 52 instead of 53 will be more accurate kind of value. Okay. So anyway, so this equation becomes now in this substitute the coordinates of the point P. So and from that you will get the answer. So this will come out to be almost 19 feet. So H will come out to be almost 15 feet. So I've still done a bit of approximation, but answer is more or less accurate if you do approximation up to first place of decimal. So that was the 9th question. Now moving on to 14th.
So what was the use of 7 feet?
What was the use of?
7 feet that was given.
See, from that only we found out this. See, we are substituting the y coordinate as 4 plus hy because he's 7 feet above the ground and my x-axis is 3 feet above the ground. No?
Okay, sir.
Yes. Okay, so let's understand the 14th question. So pretty much similar type of question. The angle of projection, speed of projection is given to you. But here, time is given to you. The stone strikes at a time of 5.5 seconds. So from that, you have to find the height of the cliff, the speed of the stone just before impact, and the maximum height above the ground. Okay. So in this, you will have to use the time-based equations. So let's understand this question. So it's given to us that we are projecting something at t equal to 0 with a speed which is given 42 meters per second at an angle of 60 degrees. And then it's also given that it goes and strikes somewhere on this cliff. With a velocity v at a time of 5.5 seconds. So the height of the cliff is h, and the maximum height the projectile reaches is capital H. Then we have to find small h, capital H, and this impact velocity. So just try this out. Use the time-based equations. Taking your axis like this, take your y coordinate as u sine theta t minus half gt square. Now at t equal to 5.5 seconds, your y coordinate should be h. You can find out that h. And then the next thing is, once you found that, so maximum height capital H will come from formula. You find that out, okay. And as far as v impact is concerned, x component of velocity is u cos theta, y component of velocity is u sine theta minus gt. So substitute t equal to 5.5 seconds to get the impact velocity as vx I cap plus vy j cap. Just try this out, people. Okay, so people hope this is clear. Okay. I think you can work out the question from this point onwards, right? Akshat?
Yes, sir.
Okay. Now let's come to question 21. Next. So question 21, like this again, it's that kind of situation. 3-meter wall at a distance of 120. If it leaves the bat at 45 degrees and 1.2 meters above the ground, what is the initial velocity? So again, just use equation of trajectory, okay? But just be careful when you are drawing the diagram. So let's go through that. 120 meters is the distance, 3-meter wall, but it's hit from 1.2 meters above the ground.
Okay, sir.
So this is the ground level. Let's say this is the wall, which is 3 meters. So it is projected from somewhere here, let's say, which is sorry, 1.2 meters above the ground. Now, it clears the wall means that we have to assume that it just about touches the wall top. Okay. So this is the thing. So this point's coordinates, we write the x coordinate as the distance of the wall, which is given to us as 120 meters. And the y coordinate will be 3 minus 1.2. So at this point, x coordinate is 120 meters. Y coordinate is 1.8 meters. Okay. So u is the unknown quantity. So equation of trajectory. So that equation is y is equal to x into 1 minus x upon r will be u square sine 90 degrees by g. So u square by g, like this. Now in this equation, substitute x and y like this. G equal to 10 or 9.8 meters per second square, whatever. According to that, you will get the level of accuracy. So you can find out from this. So that's question 21. Let's move on to question 24. Is it or check? Yeah, 24, 25. These two questions we'll do next. Because I think it should not be too much of a problem completing this question 21 also. Just one small calculation left. Okay. So let's move on to 24 and then 25. So go through these questions we'll discuss. Okay, so people, let's go over the 24th question. So cathode ray tube is basically something that ejects electrons. Okay. So we don't really have to worry about the functioning of cathode ray tube exactly in that sense, but electric field exerts a constant downward acceleration of this much. Okay, so it means that we have to just understand that in this particular situation, instead of the downward acceleration being g, acceleration due to gravity, which is 9.8 meters per second square, the downward acceleration is because of some other force, which is electrostatic force coming from the electric field, and that has a magnitude of 1 into 10 raised by 7 centimeters per second square. You can see it's much stronger than gravity. No? It's 10 raised by 5 meters per second square. So we have to just rewrite the projectile equation. Instead of taking the acceleration as minus g j cap, we have to take it as minus of this value, which is 10 raised by 5 meters per second square j cap. So the vertical displacement of the beam in passing through the plates and the velocity of the beam as it emerges from the plates, the distance between the plates is given to us. Okay. And speed of projection is given to us. 2 centimeters the distance and speed is 10 raised by 9 centimeters per second. So you may or may not convert it to meters per second. It really doesn't matter. We can use centimeters second as the system of units. CGS system also we can use. Okay. So essentially the idea is like this, that you have two plates like this. The distance between these plates is 2 centimeters. Okay. And you're creating some situation whereby there's like a hole in one plate and electrons emerge from here because of some other apparatus over here. Electrons emerge from here with some horizontal velocity, and while they emerge from here, in this region there is an electric field present. So there is an electric field. Now electrons are negatively charged, so in an electric field pointing upwards, they'll experience a downward acceleration which is given. So they will move in a trajectory like this. So when I see the side view, it's basically like a case of horizontal projection, but only g has to be replaced with the acceleration due to electric field. So this is the speed of projection, but the actual trajectory will be like this. So by the time it reaches here, it is horizontal component equal to t, and this distance through which it falls, that also we can calculate. So u is given to us as 10 raised by 9 centimeters per second. This gap is 2 centimeters. Now suppose it emerges here at t equal to 0 and reaches this point at t equal to t. So 2 centimeters should be equal to ut. So from that we'll know the time. So the time is 2 nanoseconds. So in that time, it has a downward acceleration of 10 raised by 7 centimeters per second square. So the vertically downward component of velocity will become this. Or you can say 0.2 millimeters per second. And that vertically downward displacement very small downward displacement. Because the whole process is very fast. Right? It's just taking 2 nanoseconds. Okay, so hope this question is also clear. Now coming to question 25. Okay, so let's complete this 25th problem. Particle is projected. Wall is at a height h, but at a distance a. So you can see that three informations are given to us. One is the position and height of the wall, and the other is the overall range. So from this, how we can calculate the value of u, the angle of projection of, the speed of projection of the projectile most easily. So again, if we think in terms of what is the easiest method, we should not involve time. So that means we should use equation of trajectory. So one assumption could be that the wall is here, in which case this distance is a, and this distance is h. On the other hand, the wall could also be here, in which case this distance would be a. But anyway, the range of the projectile is b. So once again, the equation of the projectile taking a normal x and y axis is that y is equal to x tan theta into 1 minus x by b हो जाएगा यहाँ पे, because the range is equal to b. Theta is unknown. Okay. Now this point here, it has what coordinates? It has x equal to a, y equal to h. So from that we can get that h is equal to a tan theta into 1 minus a by b. So from here we can get tan theta is equal to how much? bh upon a into b minus h. So once we got tan theta, we can get the value of u, because the range is equal to b. Now, are you familiar with this formula that sine 2 theta can be written as 2 tan theta upon 1 plus tan square theta? ये formula आपने देखा है?
Yes, sir.
So you can use that. Okay. So it will become little algebraically lengthy to solve, but so u square into sine 2 theta की जगह हम 2 tan theta upon 1 plus tan square theta substitute करेंगे. Okay. So just cross multiply, so this will become ab into b minus h. ab, so minus, this will be just b into g. And now substitute this value of tan theta. So you get u square So just now you have to algebraically solve this term. Simplify it and get the value. Okay, so that's the 25th question. Okay, so since the doubts are cleared, we'll just do a practice question with projectile on inclined plane also. Okay, so let's do another example problem. So we have an inclined plane at an angle of 53 degrees. And from here, we are projecting particle like this at an angle of 30 degrees at a projection speed of 20 meters per second. Take G as 10 meters per second square. Now, as the projectile takes this kind of path, at some point of time, it also reaches a maximum distance from the inclined plane. And it falls on the same inclined plane at a range of this much, at a time capital T. So find that is the maximum distance from the inclined plane. The time of flight and the range on the inclined plane. Okay, just try this out. Okay. Okay, let's check out the answers. So what we'll do is we'll take the x and y axis like this. This angle is alpha, and the projection is happening at an angle theta. So we've got this is our initial velocity, and our acceleration is g into minus sine 53 I cap, sorry, plus sine 53 I cap minus cos 53 j cap. So the acceleration numerically will become 8 I cap minus 6 j cap. So from this now we can write, as the projectile moves at any point of time, its coordinates can be written like this. X as a function of time will become 10 root 3 plus 4t square, and y as a function of time will become 10t minus 3t square. So from this you can see that, first of all, at t equal to capital T, y coordinate is 0. Okay, so capital T will be 10 by 3, that's correct, 3.33 seconds. Okay, x coordinate will be r, so r will become 10 root 3 into 10 by 3 plus 4 into 10 by 3 squared. So 100 by 3, if I take common, I have root 3 plus 4 by 3. So then we can solve that a little more, but basically 100 by 3 into 1.73 plus 1.33, approximately something like this. So that is the range. Now the more critical thing is, this is the maximum value of y, because the y coordinate is the distance from the inclined plane. So basically we have to find y is maximum. So if you think of y as a function of time, you can see that your y is behaving like this. So it will reach its maximum value at 5 by 3 seconds. So d maximum is the value of y at t equal to 5 by 3 seconds. So 10 into 5 by 3 minus 3 into 5 by 3 squared. So 50 by 3 minus 25 by 3. So this is the value of the maximum distance from the inclined plane. Just minimizing this a little bit, pretty standard things. Okay, you have to just write the equations according to the inclined axis, inclined system of axis, x and y axis being inclined instead of being horizontal and vertical, same as you do in projectile in Newton's laws also. And then just interpret the question with the proper data. Rest it's pretty standard. So hope this is clear to all of you. Okay. So very good, Siddharth, your answers were correct. This will be very close to 100 meters. Slightly greater than 100. So anyhow, with that we complete projectile motion today. Next week we will continue ahead with relative motion. So you can start looking up the theory and concepts after your major test is completed on Sunday. So you can look at the next part of the theory from Resnick Halliday or H.C. Verma or even NCRT for the concepts of relative motion. We'll be discussing that. So that's it for today. People wish you all the best. Have a nice day.
Thank you, sir.